Space arrays arrived in a March-long Codechef challenge, and let's read the prompt and find an optimized solution to this problem. So the question says, finally progress reached the Madoka family and she decided to play a game, sensational game Space Arrays with her little sister. Now there are a few rules that the game follows. So it says that initially there is given a sequence A1 through AN. So initially we are given a sequence of A1 through AN, and the player alternate turns. So in alternate turn the player plays, and in each turn what we have to do is we have to select any number according to our choice, and we can upgrade it to, suppose say we select A of 2, we can upgrade A of 2 by A of 2 plus 1 and put it back in the sequence. Right now the rule of the game is that we have 1 to n if there are n numbers given. So we have 1 to n, and we'll have to find that is there any permutation of 1 to n possible for which a of I is less than equal to p of I. Is there any? एक भी होगा तो चलेगा. तो in that case this condition must satisfy. If this condition satisfies, then the current player wins, and there is a chance for the next player to play the game. But if it doesn't happen, the current player loses, right? Let's understand this with the help of an example. Let's take this example of 1, 2, 3 and 3. So I said that we have, see, 1, 2, 3 and 3, there are 4 elements. So 1, 2, 3 and 4 are my 4 numbers, right? Now we'll have to see, now suppose the first player comes in. Now suppose he selects this 3. He'll have to upgrade this 3 by 4. So now the sequence is 1, 2, 3 and 4, and we can clearly see that this follows, this one permutation follows this principle, a of I is less than equals to p of I for every value of a, the sequence. Now when the second player comes in, if he upgrades any one of this, if he chooses any one of the value, and he'll have to upgrade it. Suppose he chooses 2, he'll have to upgrade it to 3. Now we can clearly see for this value 3 is greater than 2, right? So a of I becomes greater than p of I, which is invalid. So second loses here, right? So so this was the question. Let's take another example, say 1, 2, 2, 1, 5. What we should do in this example is while solving the problem is we should sort the sequence. Let's sort it first for a better understanding. 1, 1, 2, 2, 5. Suppose we sort this, right? And we sort this, and we are writing our permutation sequence 1, 2, 3, 4, 5. Now suppose someone comes and starts to play this game. What will he do? Suppose he takes this, he upgrades it to 3, right? And it is possible because 3 is less than 4. So I do this. Now the second person comes in and he also upgrades this 3 to 4 back again, which is also a valid step. Done. Now the first player comes back again and he decides to upgrade this 2 to 3, which is a valid case. Now the second player comes in and he decides to upgrade this to 2, 1 to 2. He does that. Now see that when the first player will come again, if he upgrades any one of these values, suppose he upgrades 5, then he'll have to write 6, and that would violate the condition a of I is less than equal to p of I. So first loses and second wins in this case. Approach for the given problem. Suppose you are given a sequence. The first step that you must do is you must sort the sequence. So first step is sorting. So 1, 3, 3, 4. Suppose you are given this. So you must sort the sequence in this order. The next step that you must do is that you need to check that whether if the elements if each of this element, we scan through the array and we check whether each of the element is greater than the index plus 1 value of it. If yes, then second wins. If yes, then second wins. Now I'd encourage you to find the better option of solving it. There is an algorithm that you can design from the test cases, from your understanding of this problem. Any confusion, any doubt, you can ask me down below in the comment section. Thank you.